Finding the derivative from first principles. Now, before we dive deep into this topic, let's remember that in earlier grades we learned about simplification of expressions. We used to have questions like this. This is the first one here, right? This is the first one, the second one, and then the third one. When we were in grade 10, or rather in lower grades, we used to simplify this. In fact, it started way back in grade 9 or in grade 8, right? So we used to say, okay, I would say x times x is x squared, and then x times 3, it would be 3x, right? And then what if we had something like this, whereby it's a binomial and a binomial, meaning two terms times two terms? We would say, what is x times x? We would say x squared. X times that would get 4x, and then negative 3 times this, that would be negative 3x, and then negative 3 times 4, that would be negative 12, right? Because negative times positive is negative. Okay, so this is what we learned in lower grades. Now, challenges that you're going to find in calculus, especially this part whereby we're talking about derivative from first principles, is not that you won't be able to solve problems, but is that you might make mistakes along the way because of the background knowledge here. So it is very much advisable for you to go back to that and practice how to solve expressions. Okay, so without wasting any time, this is the formula that we use here whenever we're talking about the derivative from first principles. So this is the formula that we use. We say derivative of f is equal to that. You say the derivative of f is equal to the limit of f at x plus h minus f at x over h as h tends to 0. Now, if you want to know where this formula comes from, you are welcome to go to my previous videos where we thoroughly explain where this comes from. Okay, but in this video we are only going to use it to solve problems such as this one you see here, right? So the first question says, find the derivative from first principles if you are given the following. So our f at x is equal to x cubed, right? Our f at x is equal to x cubed. Now please know that this is always given, so it means you are always given your f at x. Okay, what is left for you to find is f of x plus h. So immediately I get a question that says I should find the derivative from first principles, I start by finding my f of x plus h. So how do we get f of x plus h? This just means where we see x, we're gonna put x plus h in this way. So to get f of x plus h, I'm going to say where I see x, I put that. This is x, right? I'm gonna put x plus h, and then I say all cubed. Please, it's important to use your brackets. I always stress brackets. Please use your brackets. Now this means that this is the same as saying x plus h and then times x plus h all squared, because remember, this bracket times that bracket, the basis would be the same. So when you add the exponent, remember the exponent is 1, you get 3, right? So I'm gonna do it in two ways, a quicker way and then a bit of a longer way, okay, for all of you guys, to accommodate all of you guys. So the quicker method, right, the quicker method is the following. So I'm gonna say my f at x plus that is equal to x plus h all squared. Then what I'm gonna do is that I'm gonna say I have x plus h into, now here I'm gonna say the first term, then I square it, then I'm gonna have x squared, then I say plus the second term, I'm gonna square it, then I'll have h squared, and then I'm gonna say what is x times h, that would be hx. Then the answer I get, I multiply by 2, so the answer I would get is 2hx. Okay, so that is what we have there. Now what is left is to multiply this x by everything in that bracket, right? So what are we gonna do? We're gonna say x times x squared is what? It's x cubed. Remember, what am I doing there? I'm gonna say this times that, then I'm gonna say this times that, then I'm gonna say this times that. then I'm gonna come back to h and then do a similar procedure there, do a similar procedure. Right, so now x times x squared is x cubed, x times h squared, that would be x h squared, right? Then x times 2hx, now that would be 2h, remember x and then x, they will give us x squared, right? And then here I'm gonna say h times x squared, that would be h x squared, and then I'm gonna say h times h squared, that would be h cubed, and then h times 2hx, that would be 2h that would be plus 2h squared x, because h times h is h squared, and then we have 2 and x, that's why we wrote it like that. Then after that we collect the like terms, right? If we can check there, this and which one and this, they are like terms. We have h squared x. I need you to know that we always prefer to write x as the last variable. So this, I'm actually going to rewrite it. Instead of writing it as x h squared, I'm gonna rewrite it and start with h squared first. So we're gonna have h squared x, okay? So that this and that are the same. So since they are like terms, we're just gonna add the numbers in front. So here is x cubed, then this one and this one, I'm gonna say 2 plus the 1 that is there. We don't write it, but it is there, right? That would be 3h squared x. And then this and this are the like terms. We have hx squared, we have hx squared. They're also like terms. So we're just gonna add the numbers in front. You say 2 plus 1, you get 3hx squared, okay? Then this one here would be plus h cubed, right? That would be plus h cubed. So this is what we have for f of x plus h. I know I said it's a bit of a quicker method. Well, it is quick, because if you try to use the other method, right, the other method that one can possibly use here is to say, okay, this one here, let's just use a green color, this one here would be x plus h, and then times x plus h, and then times x plus h, okay? Then they're gonna simplify this bracket first, right? Then when they do that, they would have x plus h into, now they're gonna say x times x is x squared, then x times h, it will be hx, remember we wanna write it like that, then h times x, that will be plus hx, and then plus h squared. So this is a bit of a longer method, but it will take you back here, okay? It's gonna take you back here, then you continue. All right, so now that we have our f of x plus h, let's remember what is our f of x. Our f of x is x cubed. So this is what we needed to find, and then this is what we needed to find. All we simply do now is to substitute into the formula, because now we have that, and then we also have that. Okay, so we're quickly going to do that. Since this is our formula, right? So what are we gonna do? We're gonna say, we're gonna write lim. Remember, you always write this lim and h to the power 0, unless if you are now substituting. Check, if you were to substitute h as 0 here, you're gonna have undefined, because we're gonna have a over 0. Whatever is on top is this over 0, or rather we would have all of this over 0, and that is undefined, because anything divided by 0 is undefined. So we are not going to substitute h as 0, but instead we have to simplify first. So when we simplify, we substitute f of x plus h. This is f of x plus h, remember, this is our f of x plus h. So I'm gonna write x cubed plus 3h squared x, and then plus 3hx squared plus h cubed, and then I'm gonna say minus, what is f at x? F at x is x cubed, so I'm gonna say minus x cubed. Good people, remember this and that, they are not like terms, because here you have h squared x, here you have h x squared. So here x is not squared, here is squared, so that is not like terms then. Okay, then we have as h approach 0, then we have all of that divided by h. Okay, so now what are we gonna do? We're gonna say this is gonna cancel that, because x cubed minus x cubed is 0. Basically, if things are the same but they have different signs, then they always add up to 0. So that's why we just say they cancel out. Okay, so what are we left with there? We're gonna have the limit of 3h squared x and then plus 3hx squared and then plus our h cubed. That is all divided by h as h approaches 0. Now that we're at this stage, can you see that we have h here, right? We also have h here, and then we have h there. So what are we gonna do? We're gonna take our h as a common factor. So we're gonna say we have the limit of, I'm gonna take h out, then what am I left with? I took one h, there are two of them, it's h times h, right? I took one of them, so I'm gonna be left with 3hx. I'm left with 1. Okay, I had two of them. Here, when I take out h, right, what am I left with? I'm left with 3x squared. Okay, then here there are 3 of the h, right? So if I take out 1, it means I'm left with 2. Okay, I'm left with 2. Then that is what we have there, all divided by h as our h approaches 0. Then what are we gonna do? This will cancel that. Then when they cancel, it means we are left with lim, right? We are left with lim of 3hx plus 3x squared plus x squared plus h squared. Okay, and then as h approaches 0. Okay, now that we no longer have a fraction, now we can substitute h as 0. Okay, so this part here, we're gonna substitute h as 0. When we start substituting, this disappears. Okay, this part here disappears when we start to substitute. So we're just gonna say 30x, where I see h, I'm putting 0, and then I have plus 3x squared plus 0 squared. Okay, so just remember this part here, we are substituting, right, h as 0, and then it makes this to disappear. We no longer write it. Okay, so what will be our final answer? 3 times 0 is 0, 0 times x is 0, so there will be left with 3x squared, because this is also 0, so the derivative of f would be 3x squared. Then good people, you're gonna get your full marks. Okay, so that is how we get the derivative of x cubed there, right? Remember, it was the derivative of x cubed that we wanted from first principles, meaning using this formula. So we find that the answer is equal to what? To 3x squared. So we got the second one here, right? It says if you are given f at x is equal to x squared minus 3x, determine the derivative from first principles. Now I would advise that you try this first, right? You can pause the video and give it a try, and then we look at it after. Okay, and also I'll advise that you write this formula down. So we're gonna use this since they said from first principles. So we're gonna use this and then say we have f of x plus h minus our f of x, right, all divided by h as h approaches 0. So what am I gonna do? I'm gonna first start by finding f of x plus h, right? So how do we get our f of x plus h? So we're gonna substitute x plus h where we see x. Wherever we see x, right, remember this stands for x. Wherever we see x, we're gonna put x plus h. So look here, we have x squared, so I'm gonna put x plus h, and then I say all squared because outside there is a squared. Okay, and then here I have minus 3, then I see x, where I'm gonna put x plus h. Okay, Then what am I gonna do? I'm gonna simplify this, right? So I'm gonna say the first term I square it, then I'm gonna have x squared. The second term I square it, then I'm gonna have h squared. And then after that I'm gonna say what is x times h? That is hx, right? X times h is hx. Then I multiply that answer by 2, I'm gonna get 2hx. Okay, then I have here, for this part here, I'm gonna take this number and multiply inside, and then multiply inside. So negative 3 times x would be negative 3x, and then negative 3 times h would be negative 3h. So now that we have something like this, I'm gonna remove these brackets. Okay, so I'm gonna remove these brackets, right? So that we have something like this. So I remove the brackets because they are on the first term. Okay, these ones I couldn't just erase like this, that would be wrong. Okay, because they're on the second term, but on the first term you can just remove the brackets. Now what is left here, this is our equation here, right? This is our f of x plus h. Now we're going to substitute this wherever we see f of x plus h. Remember, f of x is always given. We are given f of x as x squared minus 3x. So we substitute into that formula, right? The derivative of f, right? The derivative of f would be the limit of f of x plus h. It is this part here, right? So I'm gonna say x squared plus h squared plus 2hx minus 3x minus 3h, and then I say here there is a minus. Remember, now my f at x is this, right? This is f of x plus h, right? So there is a minus there, so I say minus, then I put brackets. My f at x is x squared minus 3x, so I'm gonna write x squared minus 3x. Okay, then I divide all of that by h as our h approaches 0 there. Okay, I hope that we are together. So after that I'm gonna distribute out, right? So I'm gonna have the limit, then I will have x squared plus h squared plus 2hx minus 3x minus 3h. Then negative times x squared will be negative x squared. Negative times negative is positive, then we have positive 3x there, right? Then all divided by h as our h approaches 0. So now you're going to see there are going to be like terms there. What do we have as common? We have 3x, and then we have negative 3x. They cancel out, they give us 0. Then what do we have? We have x squared minus x squared. They cancel out, they give us 0. So what are we left with? We are left with the limit of h squared plus 2hx minus 3h, right? All divided by h as our h approaches 0 there, right? So now that we have this, we can then finish off by saying we can take h as a common factor, remember? So I'm gonna have lim of h into, I took 1h, I'll be left with 1h. I took out h, I'll be left with 2x. I took h, then I'll be left with only negative 3, all divided by h as your h approaches 0. Then this is gonna cancel that. Okay, then what are we left with? The lim of h plus 2x minus 3 as our h approaches 0. Okay, now to finish off this, we'll then say, okay, we'll have, now we're gonna substitute h as 0 because we no longer have a fraction. So we're gonna say 0 plus 2x minus 3. And please note that I no longer write lim as h approaches 0. I no longer write this. So the final answer will be 2x minus 3. So it means the derivative of f will be 2x minus 3. Alright. Let's look at the next one. As always, you can give it a shot and then we'll look at it, isn't it? So they want, given this, determine the derivative from first principles. So I'm gonna use the same formula, right? We're gonna say the derivative of f would be equal to the limit of f of x plus h minus f of x, right? For grade 12, this formula is given in the formula sheet, isn't it? So now we're going to substitute our f of x plus h. So first of all, we need to find our f of x plus h, right? So to get f of x plus h, it means where we see x, we're gonna put x plus h into our equation here. So I have 3 minus 2, then I see x. I'm gonna substitute it as x plus h, and then it's all squared, right? Then I'm gonna have 3 minus 2. Now remember, h plus x plus h all squared would be, I take x, I square it, and then I'm gonna have x squared. Then I say the second term I squared, I'm gonna have h squared. Then I say x times h is what? That will be hx, right? Then that answer I multiplied by 2. hx times 2, that will be 2hx. Okay, then after that, what do? We say 3, then this number is gonna multiply inside so that we remove the brackets, isn't it? So I'm gonna say negative 2 times that will be negative 2x squared. Negative 2 times h squared, that will be negative 2h squared. Negative 2 times positive 2hx, that will be negative 4hx, right? So this is our f of x plus h. Okay, this is our f of x plus h. So we're just gonna substitute it into the formula. So we're gonna say the derivative of f would be the limit of this as our f of x plus h. So I'm gonna say 3 minus 2x squared, and then minus 2h squared, and then minus 4hx, right? Then I say minus. After I'm done copying out my f of x plus h, I say minus. Then I say what is my f at x? Is the one given in the question, which is 3 minus 2x squared, right? Then that is all divided by h as our h approaches 0. So we're gonna say we have limit, right? It will be 3, right? 3 minus 2x squared minus 2h squared minus 4hx, and then negative, there is a 1 here, just that we don't write it, okay? But you must have mathematical eyes. I call them mathematical eyes to see that there is 1 here. So this negative 1 times 3 is negative 3, and a negative 1 times negative 2, that will be positive 2x squared there, because there is x squared. Then we divide all of that by h as our h approaches 0. Okay, then you're gonna see that there are like terms there, right, as always. So this is gonna cancel that because it's 2x squared and 2x squared. This one is a negative, that one is a positive, so they cancel out because they give us 0. They are called additive inverses, right? They were also emphasized in grade 10. So we have 3 minus 3, they are also additive inverses, so we are left with this, right? So what we are left is the limit of negative 2h squared minus 4hx all divided by h as our h approaches 0, right? Then we're gonna say we're gonna take h out, then we're gonna have negative 2h. We're just gonna take one h out as always, okay? We just take one h out. So I'm gonna left with one h here, then here I'll be left with negative 4x when I take out that h, okay? Then all divided by h as our h approaches 0 then, okay? So now this will cancel that, then we're left with lim of negative 2h minus 4x, right? Then we have as h approaches 0. So what we can do is just substitute now h as 0 because we no longer have a fraction. So we'll have negative 2 into 0 minus 4x. So the answer would be minus 4x. So this would be the derivative of f. Okay, that would be the derivative of f. And f, what was f? F was 3 minus 2x squared. So the answer would be negative 4x. Alright. Now our last one for today will be this one, right? So now how do we find the derivative here? As always, since they are saying from first principles, we're gonna use our formula there, right? So we're gonna say lim of f of x plus h minus f of x as our h approaches 0. So we're gonna start by finding f of x plus h. So f of x plus h means we substitute x plus h into this formula there. So we're gonna have 4 minus 7. Where we see x, we put x plus h, right? So then we would have 4 minus 7x, right? And then minus 7h. Okay, this is what we would have for f of x plus h. Then we just simply substitute into the formula. Therefore, our derivative would be the limit of 4 minus 7x minus 7h. Then we say minus into this, right? This is our f, remember? We're gonna have 4 minus 7x. Then we have all divided by h as our h approaches 0. So now we're gonna have the lim of 4 minus 7x minus 7h, and then minus 4, then plus 7x. Okay, all divided by h as h approaches 0. Then what is going to happen there? Negative 7x is gonna cancel 7x. 4 minus 4 are gonna cancel 2. So what are we left with? We're left with lim of negative 7h over h as our h approaches 0. Okay, so what do you think we're going to do when we've reached this point? Yes, so this is gonna cancel that. So we are now left with the lim of negative 7 as h approaches 0. So the question is, where are we gonna substitute our h now that we have something like this? Well, I'm gonna explain this in the first way, right? In two ways, right? The first way is that here, this negative 7, I can write it as negative 7h to the power of 0 as our h approaches 0. So now that, why am I putting h? Because I want to substitute h as 0. Now if I say h to the power of 0, remember any number to the power of 0 is equal to 1 except for 0, right? So it means I still have 1 times negative 7, which is negative 7. So now I can substitute my h as 0. I'll have negative 7 into 0 to the power of 0. Oh wait, looks like we're gonna hit a dead end, because when you put 0 to the power of 0, you get error in your calculator. Interesting. So does it mean that this doesn't have a solution? No, it doesn't mean that it doesn't have a solution, right? It actually has a solution. When you go deep about limits, then you'll actually learn that this is a horizontal line and the answer will always be negative 7 there. Okay, so I'm just gonna say to you as a take home, the limit of a number as h approaches 0 is always equal to that number. Okay, I ran out of space there. Let me just take this down here real quick. Let's write it here, right? The limit of a number is always equal to that number. Okay, so just know this. Okay, so it means if I have lim of negative 7 as h approaches 0, it will be that number as the answer. If I had lim of 8 as h approaches 0, the answer would be 8. Okay, just remember that. Okay, so this is the answer for the derivative. So therefore our derivative would be negative 7. All right, so I hope that gave you all the information you need on how to solve, or rather find, the derivative from first principles. We're gonna look at more advanced examples of this derivative from first principles, and then after that we're gonna go to differentiation rules. Stay tuned.